So, hello everybody. I hope that you had a good lunch and a good cup of coffee. You will need it, not just for this talk, but for the upcoming ones. So, anyway, you're reverse engineers here, right? So, you should be able to handle. So, brief introduction about myself. So, during the day, usually I'm working as director of a ZT cybersecurity lab in Rome, and in the night, I'm usually breaking or making hardware stuff, depending on the mood and on the day. Disclaimer, the content of this presentation is the result of an independent research, so please don't blame my previous and actual employer for the upcoming slides. Thank you. So, first of all, as the title in the first slide, in the opening, we are talking about physical access control systems, in particular biometric ones based. So, just to give you an initial overview of the types of biometric based physical access control system we have actually in the market, we can differentiate depending on the sensor that is used in them. The most common, of course, are fingerprint that are widely deployed nowadays in multiple realities, from corporate environments to different ones. Then we have some others that are less common in corporate environments and more in more advanced environments, like military ones or specific industrial control plants or something like that, like iris scanner or retinal scanners. Then we have the facial ones that usually are not the most accepted widely from privacy point of view, the perception of the violation of the privacy point of view. And then we have voice scanners and, of course, hand-related scanners. Actually, here I put hand geometry, but there are two types, as you can see in the next slide. The main two hand-based biometric access control systems are using two different sensors. The hand vein technology one, which is a technique of biometric identification through the analysis of the patterns of blood vessels visible on the surface of the skin by using different type of length of light, like infrared and so on and so forth, and based on the combination, the structure of these veins, blood vessels on your hand, we can create a very unique pattern, or so to speak, sort of hash, right? The other one is the hand geometry. Is the longest implemented biometric type because actually this kind of technology was already in use at the end of 80s, surprisingly. I didn't know that, but I discovered later on. Actually, all these, let's say, hobby research was started because one day I was visiting a factory plant where a friend of mine was working, and I noticed that in the factory line, the production line, instead of using the classic fingerprint sensors and access control, they were using this strange device where you put your hand. And I was like, why such thing? I thought at the beginning, because of the need of higher security. Actually, it was the opposite. Because we will see later on that these kind of sensors are not as precise as the latest versions of fingerprint sensors, like capacitive-based fingerprint sensors. So they give you a certain grade of security, but not as secure as other type of biometric systems. Anyway, how it works, the hand geometry, just to give you an idea of what is the technology behind that. Well, first of all, the sensor is a sort of camera, which once you insert your hand on this device, on a plate, guided plate actually, which will position your hand in a very specific position, will acquire a image of your hand from different point of views. So from the top and from the sides through the help of some angle mirrors. So once this image, the silhouette of your hand is acquired, 31,000 points are analyzed and 90 measurements are taken. The measurements can be, for example, the length of the fingers, distance between the knuckles of your hand, the height, the thickness, the width of hand and each finger. So the idea is that after the acquisition and all these measurements process, what is the output of all this enrollment, if it's the first time you enroll your hand with this device, is a 9 bytes array, which usually in the manuals and is called as is also known as hand template. So it's a sort of hash. We will see later on that is not is not as precise as a real hash because there is some sort of scoring. So every time you insert after you enroll the first time your hand and a specific hand template is created, every time you need to enter again, you need to scan again your hand. Once acquired, the newly entered hand it will create a new template and then try to compare the two templates. So there is a score from 0 to 100. The lower is the score. It means that the closest is the closest are the two acquired hands. So in this case, there is some certain level of degree of freedom from each acquisition. Why? Because as it was designed to be used in environments like, so to speak, dirty environments or polluted environments, like, imagine like a factory where workers in the product line, they use factory line, they use gloves. So in theory, they can still use the gloves, while wearing the gloves while trying to, access that part of the building. So that's why there is that certain degree of freedom. And we can use that to exploit from, physical security point of view, these kind of devices. Where are used mainly these kind of physical access control system or clock timing? Because time clock or hand punch is usually healthcare, industrial site, chemical plants, food manufacturing, airports. In the past, I found on the internet some information about some airports around the United States that were using these in the past. Of course, for obvious reason, luckily for them and for us, they got replaced with higher security types of biometric access control system, like the fingerprints or retina or eye related biometric systems. So just to give you an idea, I found online, like for example, this tweet from this chemical manufacturer that was even promoting the fact that they installed these kind of devices on their facilities. So that was good or sin, but bad obstacle, because then it pushed me even further to eventually buy a couple of them and start working on that. So the target is this device. It's called hand key or hand punch. In theory, the type of device is called hand punch, and practically is quite expensive compared to other types of access control systems you can find around. And but still, I was motivated enough. So eventually, on eBay, actually, you can still find some of them on eBay. So if you want to play around, there are still some around. And eventually I ended up buying a bunch of them on eBay. The sad part is that they were the dismissed one from, real scenarios. So they didn't have the locks. So they were just closed and, they didn't have manuals. They didn't have softwares. So I went like in a very black box approach on trying to, first of all, setting them up. So the first vulnerability that was obvious once it arrived was the fact that from physical, in the next slide, you will see a different approach. So physical security approach, starting from the very beginning, like, the lock itself that is opening the entire device. And we will see later trying to clone my control hands to see how the sensor is, how secure is the sensor. And then we'll see from network point of view, reverse engineering, and so on and so forth. So starting from physical security point of view, the first thing obvious to any security guy is the fact that they are using a tubular lock. Already per se, the tubular lock is a failure. So from my point of view, if I would have to protect some physical access of this type, knowing that probably after opening the device, I will have access to the motherboard of the device and be able to control the relay of the electronic lock that is connected nearby, classic environment infrastructure of a physical access control system, I would have used something like a highly secured type of lock, like those high-level assabloys ones, for example. But anyway, tubular lock, what it means? It just means that security through obscurity compared to a classic pin tumbler lock. So here, what you need is just either a tubular lock tension wrench and the needle to push back the pins and try to open the lock, or just classic tubular lock pick, like in the image there, up there. Or the third option was Googling, because I'm a lazy guy and even lazy lock picker in this case. So I just checked around if there was some sort of key I can I can ask the manufacturer to remake, giving them some code. Usually, sometimes happens like that. Eventually, I ended up finding a interesting thing. All these devices, not just this model that was the HandKey 2, but all the lines of these kind of devices from this manufacturer had in common one single master key. So you just need to buy one, and you can open all of them, everywhere, anywhere. So that was already a failure. That's why I mentioned in the title pitfalls, because this was just the beginning of the journey. So once you pop open the device, on the back of the device, you see some interesting information about the pinouts, which is always good. Then you don't need even the manual. So at this point, I didn't have manual nor software. So my journey continued by the time. So at this point, what I realized is that there was first thing first. Usually, when you do some red team engagements or you have access or physical security audits, you always check the physical access control system for anti-tamper switches. So this is one is another vendor, another device is a reader. The point is that usually there are anti-tamper switches. And 90% of the times I checked during some real engagements, they are never used. So that's already a failure, but the failure is not from the vendor, but is from the whoever implemented this physical access control system in that specific video. So, just going back to this device, as you can see, there is no mention anywhere any anti-tamper device. So I tried to check deeper on the motherboard, and effectively there was no anti-tamper switch. This is already a failure for this kind of devices that are used also as physical access control systems. So anytime you open with the master lock one of these devices, there will not be an alarm triggered remotely to the security guard's room. So you can eventually tamper, you can do things, right, in it. So what's next? Well, once you open it, you can notice different things. The first thing is the reset switch. The reset switch allows you to do, well, as it says, a factory reset. So what happens when you press it is that you delete all the data contained inside the device itself. So it forgets about all the hands enrolled, all the users, even the super admin user. Everything is lost forever. So in that case, you just close it up and it's sort of denial of service. No one can log in, can access that door unless the supervisor will come and reset re-enroll himself as supervisor or super admin, call it as you want. The second thing is that once you press the reset, since it deletes everything, it goes in factory mode. So with that factory mode, then you can enroll yourself as super admin. Just decide your ID or PIN code. Roll your hands 3 times, so scan your hands 3 times, and that's it. Then you can enter by inserting the same PIN code you just enrolled, your hands as well scanned, and that's it, you're in. There is another way, less suspicious and less, noticeable from, security guards or whoever owns this physical access control system. The MacGyver-style paperclip. Because as you can see here, you just need, to be able to read English, actually. If you see here, there is one pin in the terminal called lock, clock, and D1. D1 stands for the data 1 bus of the vegan, because it's using also the vegan, the usual, all the from 1970s vulnerable protocol of physical access control system. But in this case, we care about the first word, lock. So what happens is that just with a paperclip and a master key of that you can buy for $6, any of these devices can be popped open. No alarm will be triggered because there is no anti-tamper switch. And then with the classic, MacGyver-style paperclip, we can trigger the relay that will open the lock. So in this case, it's classic paperclip thingy, and you just need to pull down to ground that pin, and the door will open. So all this set of things is leading to to good times for red teamers out there. So then the next approach, passing from reviewing different failures from physical point of view, from physical security point of view, I passed to the next step, sensors. So in this case, I wanted to usually, as I said at the very beginning in the intro, during the night, I break things. So usually, I like to break biometric access control system, fingerprints, and so on. And sometimes you find some funny things. That's why I started, in this case, with the silicon hand attack, I started with a very dumb way of testing. So I thought, let's see how stupid is the sensor in this case, or how easy is possible to trigger, a real positive. So I started by buying, Halloween hands and stuff like that, but they failed, obviously, luckily for the vendor. And then I tried to create scans of my 101, scale 101 of my hands, and then try different thicknesses. And luckily, all of them failed. Then I wanted to step up a bit further, and I thought about 3D scanning. So at the beginning, I started to investigate which is the most cost-effective way to get a 3D scan of a victim hand in a way that is not just, from research point of view, a lab-controlled environment. So looking around, there were some options too expensive for my budget. So then I ended up with a €5 app from the App Store. So for iOS, for mobile iPhones, which is this Trinio, TRNIO 3D scanner app, which practically what it does, you just need a lot of photos and videos of the target hand, and then it is able to reconstruct in 3D the acquired target. So in this case, with my control hand, of course. But this already was, I wanted to try this step before the next slide. Would you see I did another type of attempt, but that needs physical access to the target hand, which is undoable in a real case scenario. So I wanted first to try some middle way. So in this case, this approach is still feasible remotely, as soon as you have a lot of images and videos of the target hand. So in some cases, it may be doable, in a real red team engagement, let's say, a long-run campaign of red team engagement. So the idea here was that I acquired a lot of photos and videos with this app, with the mobile phone. Then I fed this mobile app with these photos and videos, and eventually it created a 3D version of my control hand. And then what I did, I fed inside a CAD designing tool in a way that I tried to clean it up as much as I could, the imperfections, and then printed in with a 3D printer and PLA, and then I created a mold with alginate in a way that from the negative mold of my control hand, scan 3D hand, I was able to pour inside a B-component silicon-based compound, which allowed me to recreate my positive, a clone of a simil clone of my hand, actually. Well, the results were not the best I could have achieved, but still, again, I wanted to remark that I wanted to be as lower budget as possible. So at the end, considering 50 attempts, so I tried 50 times to log in with this hand instead of my real one, only 2 times I succeeded. So in this case, if we look from Mythbuster point of view, is plausible. The reasons why it's still acceptable for me is that if I would probably repeat with a higher quality acquisition of the hands, like medias, like videos and photos, and probably use not this €5 mobile app, but some better, acquisition software, probably I would end up with more successful attempts. So, but still, as Mythbuster style, plausible, still one. So the next step was something that is pretty unreliable in a real world. I mean, to create this kind of mold, higher precision mold, clone of my hand in silicon, you need 3 minutes of the victim's hand staying still. So either you drag him or, so from a research point of view, we can demonstrate, we will see later that we can demonstrate that the sensor can be bypassed. From a red teamer point of view, if there is some red teamer here, will nod and say, yeah, this is undoable. I agree with you, because it's the same with cloning fingerprints. There are some cases you can bypass from a lab perspective point of view, a fingerprint sensor, but from an operational point of view, is undoable, right? So this is the same case. So this case is pretty much successful. Well, it was successful. Like every time I tried to, scan, acquire the clone hand was working. So I would say 99% is successful because, Murphy is always there. But, every time I tried, I was always able to log in with this hand. So the idea is that, this is Jimmy. We called it Jimmy in the lab. And, you try to log in. Of course, why I use the silicon base, because you can, move the hand on the plate. And we got a 79% score, which is, as I said, the lower the score, the closest is the newly acquired hand with the initial one template. So as you can see here, my hand is 35. Okay, it was too fast. Instead, the first time I acquired the hand was like 79. So in theory, the sensor detects that there are differences, but they are designed exactly to allow users of these devices to have dirty hands, like imagine mechanics that they have, debris, black grease on them, or scratches, in case you get a scratch one day, instead of being denied, you just, have a sort of degree of efficiency. In this case, it was even 93 there, the score. So we barely passed, because if you get more than 9900, it will be denied. So, but still, from that point of view, it works. Now we reviewed from physical security point of view, from the sensor security point of view, then we passed through the usual network security point of view, because as you know, physical access control system usually in the past were connected through RS-485, RS-232, and eventually they passed finally to TCP IP-based connection, right? So in this case, this device is similar, is acting as other physical access control systems. Once you connect to a network with DHCP, it gets an IP, and then eventually what you do, you scan with Nmap, right? And eventually you will find this port, standard port 301, open, TCP, which is funny because it says, the service says, Nmap stores that as a Nessus server. So it was like, oh, interesting. Anyway, so after a brief fuzzing campaign to see how it was reacting, the device, nothing. Literally zero. It was like, it didn't care about nothing there, even though it was marked as open because the TCP handshake was completed. So after the TCP handshake, nothing was there. I wasn't able to get any reply from the device, so I started to look around, doing some, OSINT and Googling around, and eventually I thought, for sure there must be a software out there. It's just that I didn't receive it because I bought used and from a dismissed building on eBay. So looking around, I figured out there was this lovely tool called handpunch admin, and already in the once you open, you immediately see that the port is already preset to 3001. So I thought, okay, it's good direction. So what I did, I just placed the IP of the device and pressed test, and the first, it connected. The first thing I thought is, wait, it didn't ask me for passwords yet. But I thought, okay, it's just maybe just because I pressed test, it's doing some sort of magic, wake up packets and then just ping, and the authorization will be later on. Then I pressed like the button pull users, and I already had a couple of users there set up manually from the device itself, always with my hand, but didn't matter much. So they had different IDs and different names just for secret information. And eventually, it pulled without asking me any password. So I thought, like, what? So maybe encrypted, right? And hard-coding inside the handpunch. And I thought, wow, that's bad. So maybe half of you would have already started with Ghidra or IDA Pro, starting, disassembling the executable. Since I'm a lazy reverse engineer, I started with the networking point of view. And with the networking point of view and try and errors and sniffing with Wireshark, I figured out the following. So first of all, as soon as you press either test here or any other command here, what it does, the device is from the software, so the PC, let's say, it sends this packet, always the same, to the device. So at that point, I thought, interesting. When I send only this packet, the device wakes up and starts to be, to speak, talk me back. So I called it the wake up packet, right? And it's always the same, by trying and retrying, sending multiple times the same type of buttons, like the test one in the desktop application. I was always getting the same packet sent and the same reply back. So I inferred that was some sort of wake up magic packet, and that's it. The next packet, though, was even more interesting, because maybe I thought maybe somewhere here there's some hard-coded password. Still, I didn't have clear mind yet about that, but I continued, with the next packets. And the next packets showed me another thing. And the fact that once this packet is always the same, both packets goes in couple. They are always sent at the beginning of every communication that is initiated by the software version to the device. So the second packet reply was like max drive, all in clear text, and is HP4 blah blah blah. And then I noticed that was exactly what was written on the device once you boot it. So it means that is some sort of, well, first of all, we realized that is probably very sure, very likely plain text protocol, because we see exactly. So this is blue is what the hand punch. So what is this device is sending me back through TCP. So then the protocol is in clear text. Good, we can manipulate somehow. And second thing, doesn't look like there is some sort of authentication screen anywhere. So I continued with try and errors, and actually I tried to do some real actions like create a new user. So in this case, I created a new user with a user ID or also PIN code, because actually you need to insert that ID PIN code before scanning your hand to get access to the get past the hand punch. So I created a new ID user 666, and then I named that user hacker. So then here I sniffed again. So the first packet is always the usual one, never changing, wake up packet. It gives me the idea that there is no password somewhere. The second one again, query the user model and the type, the version. And then the third packet, I noticed that there was the 66 I inserted from the software point of view. So I thought, okay, maybe that's the packet create new user ID. And then this one, again in clear text, but this time was from the PC to the hand punch, was containing exactly the string I inserted from the software point of view. So I thought, okay, it's definitely plain text. Doesn't look like there is any session handling part in the protocol. Most likely, I see many times FFs at the end looks like padding. If you played with GSM mobile networks, the 2B padding is always there. So I thought that's something like that. Probably somewhere at the end there must be a CRC for sure, or some integrity check. And then later on was confirmed because by playing with the latest couples of digits, bytes, I was able to figure out that it was a CRC16X modem version of CRC. And then eventually I continued doing this kind of tests until I started enrolling a new hand. So the idea is that what happens? You create a new user, you name it with the string, with the username you want. You associate that username with an ID, which is also your PIN code, which you need to insert to log in before placing your hand. And then you start the enrolling process. The enrolling process practically is like you place your hand 3 times back and forth inside the device, and with scan 3 times, then make a median value, and then create the template, your hand template. Here, the interesting part is that, okay, this part of the conversation I was unable, still now is kind of obscure, because sometimes they are just the same requests going forward, back, and getting different replies. But it was irrelevant because I thought it was something like, practically in this period of time, I was literally inserting and removing my hand. So it's something like, on hold communication or heartbeat packets. And the point is here, once I finished the acquisition of the 3 times of my hand, I got back this packet. And this packet then was sent. So here is the fun part. So the software, the PC software, sent this packet. And the hand punch, after finishing the acquisition and created a hand template, sends back this data. And until here, I was not sure what it was. But then I see immediately after, you see another request made by the software with the ID of my user and the same data, 64, 70, 73, and so on and so forth. So, and then if you count all of them, is 1, 2, 3, 4, 5, 9, which is exactly the 9 bytes mentioned at the beginning of the hand templates. That's how they are describing the definition of this kind of hand geometry recognition based system. So there is a 9 bytes data for hand template. So I connected the dots and eventually figured out that this was the hand template. And then I thought, usually in a physical access control system with a RFID based, most of the time, once the fingerprint is acquired the first time, it's not sent back to the server or the PC of the security guard. It's usually stored in a secret part of the reader itself, because of security reasons. In this case, this device is sending back the template, and that's very useful because instead of trying to extract it directly in the memory of this device, I was able to just extract my hand template and keep it, and then eventually, due to different facts, like the lack of authentication, lack of session handling, weak integrity routine for, the integrity of the packets, total absence of, any security feature out there. With that template in my hand, so to speak, I'm able now to push remotely my template, so I can enroll remotely without any security feature blocking me. A new hand to any device I want, as soon as I know their IP and the TCP port, if it's not the default one, I can create a new user remotely with my hand. So the idea is that at the end you end up like literally, as soon as you identify one of these devices and you know the IP, you can just walk by the entrance of where there is this device used in nearby the door, connect through the LAN eventually, or we'll see later even through internet, sadly, and just push enroll you as a new super admin with your known template, and then you can just log in and that's it. So in order to achieve all of this, I created a simple tool that I will release after the talk today on GitHub, which I called HandPwner tool suite. There's no comments about my developing capabilities. I'm quite, I'm not the best developer. That is why I usually call myself part-time. So in this case, what you can do, I created a scanner which scans. Practically, you need to send some specific packets, like the wake-up packet. So the idea is that with this we have sort of Nmap plugin. Actually, I was planning to make a pull request for adding this plugin on Nmap. And the idea is you can scan the network. Actually, this is a LAN, but we'll see later you can do also with the internet level side. And the idea is that it sends you back all the information of possible vulnerable devices in the network. And actually, you can even get is brute forcing the device address, because probably at the very beginning when this device was created, was connected over not TCP, so RS485 for example. So each device had its own device address. Actually, by default, all device addresses, all these devices nowadays have 00 value as default device address. But I made a loop that eventually scans also for other device addresses in case it's not found with the default. So in this case, with the tool, we can the easiest way to enroll a malicious super admin is to enroll, just do as is supposed to do usually the device. So you go nearby, as soon as you have the IP, you send this command, and it will start enrolling a new user, 666, which didn't exist at the beginning of this video. And then you just need to enroll 3 times. So to scan 3 times your hand in a way that the device itself will create a new template. And then once the new user is enrolled, it does the magic, communicates back with the HandPwner script, and then you can just log in and that's it. You should be in. Okay, this way is nice, but is not as fast as the other one. Like walk by with the phone hidden ready, knowing the IP, and that's why it's called known template. Because with these weaknesses we found by analyzing the protocol, we are able to create our own hand template remotely at home with a similar device, and then is the same everywhere with other devices. So it can be exported and re-imported, so to speak. So in this case, I hard-coded the template of my hand inside the script, but eventually you can use the -T to with your own hand. Of course, the prerequisite is that you need at least one time access to one of these devices to create your own hand template. Or you can use my hand template and call me and I will open the door for you. So the idea here is just, you just need the IP because the default port was 301, and what it does is just push everything there, and you're in, and that's it. So at the beginning of the video, I was unable to log in as 666, but now 666 user exists, and voila. So this is the fastest way. So in a few seconds, as soon as you know the IP of this device, you're in. So Other features that I wanted to is dumping the user IDs, because user IDs are also pin codes. So sometimes may leak some good information, and that pin code may be, reused somewhere else. So good to know, and we can dump without any alert trigger, because it's just over the LAN. So the only prerequisite is to know the IP. So regarding this point, well, this is the entire responsible disclosure timeline. After which, the end of the last meeting I had with the vendor, they informed me that they set this entire product line end of life around the time I disclosed this vulnerability. So it was already in plan to make it end of life. They just speeded up the process. The thing is that there will not be firmware updates nor hotfix released. And then I was like, okay, that's not my decision. The point is that I was afraid what happens if there are some of them exposed online, and they said, who does expose them online? And then eventually I ended up asking John from Shodan if he would implement part of the network protocol I reversed engineer in a way that we can check online with these probes on the network, on the internet, if there are. And actually there are something like that. Today I checked in the morning, there are still 1,752, because since they set end of life, more and more customers, they are replacing them, but not as fast as you can imagine. So the idea is that if right now, actually is already 6-7 months that there is this feature hidden in Shodan, available to everyone, but I never made it public. So if you go now on Shodan and write handpunch, you can see these devices. You can even see we managed to get out also not just the fact that the version or the model, but also how many users are enrolled, and eventually even the logs, because some devices may not be always connected to a software like the one I showed you before, the desktop app. So you can even see the logs out there. So you can even see who exited and entered the device. And of course, potentially you could push your hand template as I showed in the proof of concept. So yeah, the situation is as follows. I cannot comment. So just to give you some ideas, like I took one random IP out there found on Shodan, and they found something like 10,000 users enrolled, and they were like the username, name and surname. So then I tried to do some OSINT, because you can see the IP, so you can see the region, you can see actually the company to which this static IP is allocated. I tried to do some responsible thingy, contacting some of them, but they got scared and they didn't reply. So, I tried to be as more polite as possible, explain the situation, but they were not even IT people, so they got, yeah. Well, so just in case, just if you ever seen someone around with these kind of devices, I strongly recommend to inform them that the potential, threats incoming if they're exposed to ninja. That's pretty much it from my side. Pro tip: while I was writing the white paper that will be published with the slides as well, I realized that there is this handpunch.com. I will notify the vendor as well about this. They leaked all the manuals, included sort of SDK about the protocol. So later on, I was able to confirm that the wake up was really sort of wake up. It's called differently. So just pro tip: when you start the research, do also check web bug hunter. Do usually just check things. Will smooth your life in researching things. And the unchangeable password, well, this is funny. So this is the manual that I found, while writing the paper. And actually, to set up things, there is a password, which is in the manual, and is hard-coded. And they are mentioning that you can change it, but you cannot. So it's always the same password. So even if you don't have the lock to open the device, you can always access the supervisor mode with always the same password. So it's something like it was funny. I decided to leave as a reminder that always be cautious on when you review your manual or no. That's pretty much it. Thank you. Any questions?
All right. Thanks, Luca. Do we have questions from the audience? Yes, we do.
Did you ever try to learn the silicon hand as like a standard template?
Well, that's a good question. No.
No, okay.
I didn't try.
Because then we could just
I will when I
3D print our own silicon templates and...
No, actually, that's a good point. The 3D printed version of the silicon hand I didn't try.
Then we could just put it on everyone and then walk up to everyone that's connected and test it.
You are a genius. I didn't think about that.
Next level, okay.
Yeah, actually, I was giving for granted that someone that wants to replicate this attack has to enroll his own hand. But actually, at this point, it makes perfectly sense because then I just share the STL file of, you're a genius, man. I cannot see you well. Open source hand. Looks amazing.
You can even sell the pre-made silicon hand.
Oh yeah. The guy is right. I can make the community edition and
indeed. Actually, for taking the scan of the hand, I was thinking that you could put the camera in ATMs.
Guys, you are so malicious. I'm proud of you.
That's for red teaming. A red teaming tip, maybe. What do you think? Would that work?
I need yes, the idea makes perfectly sense. I'm not as good as some guys here that may play with photography about the acquisition. I mean, how detailed would be, but the idea makes sense. So probably with a good quality sensor for photographic sensor.
That's what you do when you actually put
because the idea is the same. So
okay, thank you.
It may work. Thank you.
All right. Do we have any other questions? Good. Give another round of applause to Luca.
Thank you.